All right, I'm going to real quick go through square root transformations. You're going to find that the next three sections are very, very similar. You're going to notice that the rules don't change, not much changes, just the parent function is the only thing that changes. So let's do square root transformations. So our parent function is f of x equals the square root of x. And I went ahead and typed that into Desmos so that you can see it, even though it's on my examples there. So it looks like that. And then I did a table here. So if you take the square root of a number, it's smaller because the square root of a number is what times itself gives you that number. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And you'll notice that the domain of this starts at 0 and goes to infinity. And the range is 0 to infinity. And that's because we can't take the square root of a negative number. If you put the square root of negative 16, it's not 4 because 4 times 4 is positive 16. So that's why the domain doesn't include any negative numbers, because you can't do the square root of a negative number, and there's no square root that will give you a negative number. Now, once we transform it, that will change, but you're shifting the entire thing. You're taking the square root of a positive number and then subtracting something or adding something, that kind of a thing. So you're still not going to have negatives per se, but you are going to transfer them. So the rules of transformations are the same, and you're going to notice this table shows up in every notes document that I give you. So the symbol this so before you had parentheses where if it was inside the parentheses it was a left or right, if it was inside the absolute value it was a left or right. Well, instead of inside the parentheses or the absolute value, it's inside the radical symbol. So here's my radical. So this is kind of what the transformation looks like for um, square root functions. So once again, everything's still here. I left these rules in here, so you've got 1,000 copies now. And then you're going to be asked to describe them. So just to show you, the negative in the front is a reflection across the x-axis. The 3 out front means a vertical stretch of 3, and plus 4 means I'm going to shift it up 4. So if I take that graph and I asked you to graph it, you would actually flip it upside down, vertically stretch it, and move it down 4. Well, that would be, oops, did I do that wrong? Oh, I'm sorry, that should be up 4. I'm sorry, I did say down, I meant up. So the plus 4 moves it up 4. So I'm going to move the whole thing up 4, flip it upside down, and make it stretchier this way, vertically. So that's what that one would look like. Now, you're not going to be asked to graph these right now, but you should have kind of a visual in your head of what it looks like. So for this one, the square root of x with the minus 1 on the outside, that's this one here. That's going to just shift the whole thing down 1. So if you look at the parent function, I always use 0, 0 when I do my transformations, and then I know what the general sketch looks like. So 0, 0 with this funky shape. So if I move 0, 0, I'm going to move it down 1. That's it. So you would tell me that it's a vertical shift down 1. The 1/3 out front means it's a compression or a shrink by a factor of 1/3. And then the plus 6 on the inside is a shift left 6. And that is this one here. So I moved it left 6 and I shrunk it vertically because remember, you're pushing down on it. So we're pushing up and down on it. And then the very last example, this one is a doozy. I did all of it. This one has a bunch so that you see the idea. The negative indicates it's a reflection. The 4 is separate from the negative. That's a stretch of a factor of 4. The minus 2 inside, there's a typo there, means I'm going to shift it right 2. And then the minus 2 outside is a vertical shift down 8. Now, there's a common mistake that many students make every time we do this. They see this minus 8 right here, and they think it's a vertical stretch or compression. Or they'll see this minus 4 and think that's down 4 because it's outside. Notice the order that things are written in. This is 4 times the square root. This is the square root thing minus 8. So be careful here. It's not down 4. That is the most common mistake. I cannot stress that enough. It is not down 4. You can always type them in Desmos to check your answer. If you look at this one, this is the one that we just had, that I just did. Let's zoom in a little bit so you can kind of see the numbers. But so you see that it's a vertical stretch, so it made it really fat vertically. It is negative, so it flipped it upside down. It moved it right 2 and down 8. So if you need to check your ups, downs, lefts, and rights, this is the best way to do that. The vertical stretch and shrink is a little harder to see. You're just going to have to know that the number out front means that. And then if you look at it, it's flipped upside down, so it's a negative. So use Desmos to help you. It's a really useful tool for this. So go ahead and complete the classwork for tomorrow, and good luck. Let me know if you have questions.